Today's video, we're going to talk about the hazard analysis and risk assessment, also called as the HARA. We're going to talk about what is a HARA, what is the process to do a HARA, and some examples of how to do a HARA. HARA is one of the core work products that is defined in Part 3 of ISO 26262. It's defined as the next work product once the item definition is completed. Once the item definition is completed, we have a list of functions, we have an idea of what is it that we're working on, and the next step is to do a HARA. Essentially, a HARA has two parts: the hazard analysis and a risk assessment. Hazard analysis is a systematic process to identify pretty much everything that can go wrong in a vehicle based on the functions that it's implementing. And risk assessment is if something goes wrong, how bad are the safety issues? How bad is defined in terms of a risk? And risk is defined in terms of ASIL. It can be ASIL A, B, C, D, where A is the lowest risk and D is the highest risk. There is also QM, which defines, which means stands for quality management, which generally is the case when it's really not safety, when the risk is very low. Let's take an example. We've always talked about this autonomous driving car, which can drive autonomously in a certain geofenced neighborhood. It's got this entire sensor suite, and it can drive autonomously in this college campus at less than 40 kilometers per hour. We've identified a list of functions that it's capable of executing. For now, let's pick on just one function: accelerate the vehicle. Now, for this function, we want to do a HARA. So, to recap, we had HARA has two parts: the hazard analysis and the risk assessment. We need to do a hazard analysis for this function, accelerate the vehicle. So, just thinking from the top of my head, couple of hazards that could happen is there's too much vehicle acceleration. The vehicle is supposed to accelerate a little bit, but it just accelerates a lot. Too less vehicle acceleration. The vehicle is supposed to accelerate, but it does not. Maybe it's trying to avoid traffic, but it does not accelerate. Then you have a scenario where an acceleration exists when not required. So it's supposed to go at constant speed and then suddenly it starts accelerating. These are three examples of hazards which are coming from this particular function. Similarly, for each function, you can have its own set of hazards. And we'll go in detail later as to how we can systematically identify all these hazards. But for now, we stick with this example. So for the accelerate the vehicle function, we have three hazards that we identified. Then let's go to risk assessment. Risk assessment is to see, now that we've identified these three hazards, how bad are these issues? Are we talking high risk or are we talking low risk? Now, the engineering definition of risk is it is the product of probability of a hazard into severity of a hazard. What that means is if the probability that a hazard will occur is low and the severity of the hazard is low, then the risk is low. Similarly, if it's a high probability that the hazard will occur and a high severity of the risk, then the risk is high. Then with a high and a low combination, you would end up with a medium. Same with the low and a medium combination, low and a high combination, you end up with a medium. Now, ISO 26262 has broken down this definition of risk to suit automotive development. How this is done is the following: probability of hazard is broken down into two parts. There is one part which talks about where the hazard is occurring, also known as exposure. and how controllable is the hazard, known as controllability. Together, this is the probability of the hazard. And severity of the hazard is again described by uh, a parameter called severity, which is how severe is the hazard. So let's talk about each of these parameters here. Risk in automotive, according to ISO 26262, depends on three parameters: exposure, controllability, and severity. Exposure is what is the probability that I'm in a given driving scenario. Controllability, if in a given scenario there is a hazard, how controllable is it? Severity is if there is a hazard, how bad is the injury?